Hi guys. So I'm going to talk about RxJava tonight. And in many ways, I'm trying to make this talk the talk that I hoped I got when I was trying to learn it. So please give me your feedback after the session if it was convincing or not and what is not clear yet so I can tweak it. I want to start off with a quick show of hands. Who has heard of RxJava? Okay. Who uses RxJava? That's less people. Okay, cool. So for the people who don't know RxJava, I have to quickly introduce it. I'll try to make that as brief as possible without leaving out any essentials. But I really want to focus today on why you should be using it. For me, that was really like a big pain point. I got how it worked, but I couldn't see why I would want to use it. So I'll give some examples on how you can use it in your app and some common use cases where it could be really beneficial. And if we have some time left, I'll give some practical tips about things you can run into when you're using it. Okay, so let's start off. What is RxJava? For those who haven't heard of it, RxJava is an implementation of Reactive Extensions. That's the Rx part. And Reactive Extensions is a .NET implementation of reactive programming. So what is reactive programming? I got this snippet from Wikipedia, which I have been before and didn't get. So it's a whole blob where it says reactive programming is a programming paradigm oriented around data flows and the propagation of change. This means that it should be possible to express static or dynamic data flows with ease in the programming language used, and that the underlying execution model will automatically propagate the changes through the data flow. And I'm like, what is that? Something with data flows. That's my summary. Not really helpful. So let's look at reactive extensions. That was pioneered at .NET. So what does Microsoft have to say about this? They invented this stuff practically. So this is their summary from the Reactive Extensions homepage. It says, using Rx, developers represent asynchronous data streams with observables, query asynchronous data streams using link operators, and parameterize concurrency in the asynchronous data streams using schedulers. Simply put, Rx is observables plus link plus schedulers. Well, this is actually quite true, but it doesn't tell me a lot because what are link operators? I've never heard of those things. And when and how should I use this? What is the benefit? And what are observables? So let's look at the concepts in Rx in general, and specifically in RxJava. So we'll look at observables and the observable contract. Subscribing and subscriptions, so how you use them, and operators. So observables emit data when you subscribe to them. So thereby kind of the building block of the data flow programming that they talked about on Wikipedia. You've got three events. You can emit a value, which is through onNext, and you can emit 0 to infinite amounts of data. And you can get a onError, 0 or 1 times, or uncompleted 0 or 1 times. Those are exclusive, so you can either terminate with an onError or with an incomplete, but never with both. So you don't have to complete the observable. The observable can just keep on emitting data forever, and it doesn't have to complete or doesn't have to error. It can just keep on emitting values or stay silent forever if you want. This is kind of the observable contract. All the observables in Rx behave this way, and if you build your own, they should behave this way as well. Furthermore, observables should never do any calls or emit any events to subscribers after you unsubscribe. So this is a really useful property in Android if you have asynchronous things going on. You don't want to get a callback once you went through on pause and then your app blows up. So this property of the observable contract is really useful on Android. And lastly, it is up to the observable on how to behave if multiple parties subscribe to it. So some observables will emit a unique stream to every observer, and some will share the same stream and emit the same data values to observers. So it's good to read the documentation, what a particular observer or observable does. So let's look at some examples to kind of get this going. So this is a simple way how you can create an observable in RxJava. Here we're just creating an observable that just emits 5 integers. Not super useful. We'll do super useful stuff later, but just to get kind of the concept going. You can subscribe to this observable using the subscriber interface. And then on next you receive all your values. And once it's done emitting, it will call onComplete. If something would happen to go wrong, it will throw an on error. In this case, that would never happen because it just emits those 5 values and then it's done. So this is kind of the concept. You have an observable that emits data, you subscribe to it, you receive the data, and handle the completion if it happens. And if you're not longer interested in the data, you can unsubscribe from it. So we can also modify data using operators. Operators are a big part of RxJava. So we'll do a simple example as well. I hate these examples, by the way, because they're so abstract that you don't really get anything from it, but we'll get to that. So again, we have our 5 integers, and then we can call .filter on this observable. And we give it a function that filters the data points that come through. In this case, we just filter out the even numbers, or we filter the even numbers so we get the, or we filter out the uneven numbers, sorry. So this observable even numbers represents the even numbers of the data set. And then we can call .map to transform the data points into something else. So in this case, we're transforming the integers into strings. And we have our string there, myLovelyInt, which just concatenates the integer that we received into it. So filtering is removing items, and map is changing or transforming items. So if you would subscribe to this, you would see that the result would be 2 on next events, saying myLovelyInt 2 and 4, which are the even numbers from the data set, and then it would complete. You can also, you don't have to create these intermediate observables that I created, like the myInts and the even numbers and the myInts as strings. You can just chain them all together if you want. I just added it so that it's clear how the types change through the chain. In addition to transforming and filtering data, we can also change the behavior of the observable stream. So you've got a couple of operators that change the threading behavior of your stream. So in this case, we have subscribe on, which basically tells you where the emitting of the events start. And we have observe on, and everything after observe on emits at the designated thread or scheduler, as it's called in RxJava. So here you can see we start emitting our numbers on the schedulers.io thread, which is a background thread pool, and then we observe those on the main UI thread. This is a really powerful concept in RxJava, but we'll look at why that is later. For now, it's just good to know that operators also change threading logic. Then there's also a couple of operators that implicitly change the threading behavior. So here we have a delay operator. What it does, it just delays every item by 500 milliseconds that it receives. But to accomplish that, it has built-in threading that kind of holds the item and then emits it. This is good to be aware of because every operation after that item operates on that same thread or scheduler as well. So in the RxJava documentation, there's always a little section at the bottom which explains if an operator operates on a particular scheduler or not. And often they have a version where you can explicitly pass in a scheduler if you want to change that scheduler. So this is really briefly, like really fastly, the basics of RxJava. So we emit data, we can change the threading, and we can subscribe to it, and we can unsubscribe if we're done. But then why do we want to do this? Like, this doesn't seem very useful to me. Doesn't seem to solve any problem. So this at least frustrated me a lot when I was learning this. Like, it seems obvious, it seems I get it, but I don't know why. Especially if you look at some examples, like in my case, I was comparing this to retrofit 1, and then you have the retrofit example on the left where I do an API call. And if I want to do the same API call with RxJava, I would have all the stuff on the right, which is more. Like, there's no benefit. And then I have extra callbacks that I have to deal with, but I might not have a use for them, like an uncompleted. If I just have one item, why would I need that? And this is asynchronous, but if you change it to synchronous, it's even worse. Like, in retrofit, I have just one line of code to execute an API call, and then with RxJava, I still have the whole subscribe and all the callbacks. And it doesn't make sense because, like, I would think smaller is better, like concise and stuff. But I think we're kind of overlooking some aspects here. So if we look closer to the examples, you can here see the method signatures of retrofit and of RxJava. And the most important thing is that it's not shorter or longer, but that for RxJava, the method signature is the same for synchronous and asynchronous programming. They both return observables. And the useful part of that is that you saw previously that we can apply the threading logic through an operator. So the main benefit here is that normally when you code something, you make all these decisions around threading as you go. And these are major architectural decisions in your app. And you always have these leftover things like doing a single database query or getting your GCM token, where in the documentation it says you shouldn't do it on the main thread, but then are you really going to write an async task to do that? Sometimes you do, sometimes you don't, but it's a lot of work. With RxJava, you don't have to worry about that because you just express everything as an observable, and you can decide where to do that work, like where to execute it at a later stage. So you're kind of deferring that decision, and you don't have to make that choice in your API. So let's look at some real examples. So say we would have a database in our app, and we need to fetch some account information. In RxJava, that would look something like this. We have a database class, and we call find account, and this would return an observable of an account. It's good to note that this doesn't actually do the database query. It's more like a piece of work. So once we subscribe to it, it will do the database query. This just says, I want to have some account in the future. Now we can build on top of this and say, okay, given this account, we want to fetch the homepage feed of this user. So here you can see that we do a flat map, which basically takes the account in the call, calls an API that returns an observable of homepage feed, and adds that to the chain. So flat map, it's kind of complicated what flat map does, but basically in this example, what it does, it takes an account and transforms that into an observable of homepage feed. So our observable at the second line, you can see, emits homepage feeds now using this account. So there's still a definition of work. We haven't executed anything. So then we chain on top of that a do on next, which takes this homepage feed, and as an action on that homepage feed, it stores it in a cache. Now this is all disk I/O, network I/O, database I/O. We don't want to do this on a UI thread. So we tuck on two operators to schedule this on the background thread, and we observe the emitted items on the main UI thread. So here in 2 lines of code, we're basically taking all this work, moving it to the background thread, and we only get the end result on the UI thread. So then we subscribe to that, and on next, we just have to worry about rendering the result on the screen. We don't have to worry about all the I/O and the things that happen on the background. Also, on top of that, we get a subscription that you can see in the top left corner. With the subscription, we can unsubscribe or basically cancel any work that's going on in this observable chain. So we, in the main UI, don't have to care where we are in this process and which async task or thread ball we have to cancel. We just cancel, and RxJava just takes care of the process. So if we compare this to how you would typically write this in Java, you would have a callback, probably. So you have your database object, you have a find account, you want to be a good citizen, query that on the background thread. So we pass in a callback to kind of notify when we're done. Then in that callback, we would trigger off a fetching of the homepage. Again, we have a callback, which gives us the response of the homepage feed once we fetch that, given the account. And then in that callback, we can store it in the cache. But wait, that is disk I/O, and the callbacks always come back to the main UI thread. So we have to take care of that as well. You make the ad hoc decision. What do? Wrap it in an async task, and this is your result. And now you're like, how do I cancel this if I go through on pause? Most people don't. They just let it complete and just ignore the callback. So that's not ideal. So nested callbacks are not ideal. And you can see really easily that you would mix different styles of delegating things to the background thread as well. Like you can use an async task, you can use a thread, you can use an executor service, and everybody has his own little variant on that and preference. You also don't have any control over the threading. Like you're just ping-ponging back between an executor service or a thread or an async task, and then back to the UI thread to then schedule the next piece of work, which is not ideal. It's all stuff you want to do on the background thread, so let's just schedule it in one go. So the benefits from RxJava here are that you can easily write complicated threading code. You don't have to worry about all those little bits and pieces. You also have a clear pattern to cancel ongoing work through subscriptions, and for Android, that's really, really important. So in the previous examples, you still see that there's still messy code. Like we have these chaining of observables going on everywhere. Doesn't really look very appealing. But the thing is, that's more because of the examples. In a real app, you would want to span the chaining across multiple layers of your app. So ideally, you would have an architecture that looks something like this. We have our view and our presenter. In the presenter, we do all our logic. View is the view. In these two layers, we don't do no I/O whatsoever, like no disk I/O, no network I/O, no database calls, no IPC. And then in the background, we build our observables. And these models and boxes and repositories, they can compose observables from other layers as well. So most of the time, in each little box, we only do one or two operations on the observable chain. What is important is that the model layer, everything to the right basically, just builds observable chains, but doesn't really execute it. And then in the presenter, we subscribe to that and define the threading strategy. So that means that everything you write in this right layer, you don't have to worry about threading. You just write the logic as an observable, and then later on in the presenter, you can kind of decide when and where you want to execute that. Okay. So we've seen that operators can manipulate data through map and through filter. But if you're like me, you're like, oh, my APIs just return what I need. I don't need to filter. I don't need to map that often. But you've seen that it also can do threading with observe on and subscribe on, which is really cool. But there's more. Like operators can also replace conditional logic. So this is an example of what we do in MI9 in the app around caching. So here we have a cache where we fetch our stored home page feed, and then we concatenate an API call onto that for the home page feed. So what concat will do, it just takes two source observables and it concatenates all the data points together. And then we apply a dot first. And what's really cool is dot first says I just need one item, and then I terminate. And the concat and the first work really well together in the sense that the concat is lazy. So if the cache has an item and it emits that item, we never hit the network. It just completes immediately. If the cache is empty, then we go to the network to fetch the item, and then we emit that item. So this saves us a lot of if-else statements where we grab an item from the cache, do if this is null or not, or things like that, to then go to the network. So you can see that combinations of operators can also eliminate a lot of conditional logic. And together with that, they can also eliminate a lot of state. You can also remove, in this case, the first, and then it will emit twice. So we do that as well in the app to kind of emit cached items quickly to show something to the UI, to the user, and then fetch something that is fresher from the network and update the UI on the next value that gets emitted. So far, I've shown you all these diagrams and architectures, and I've been cheating a bit because I haven't really shown you how you create these observables. So we'll look at that in a bit, because there's a lot of different ways you can create observables. And it's easier than you think. So we've seen just with integers before, but you can use observable.just as well with basically any object in Java. So the easiest way is to just wrap your API call or your method call in a observable.just. The only downside is it will create the observable and invoke the method immediately when you try to create this observable. So it doesn't defer it to the subscription point, it does it immediately. So that's not really useful for us. So most of the time what you do is you wrap it in a defer. So defer gives you an observable that executes a function once you subscribe to it. So this is useful for expensive operations like disk I/O, network I/O, things like that. Most of the time you'll have a combination like this in your code that just wraps a just in a defer. So there's different ways as well. Like you can also use observable.create, which allows you to create more an observable from scratch. Those are really tricky to get right because you have to manage the invocations of onNext and onError and onCompleted yourself. There's a lot of edge cases where you can get that wrong. So my advice would be to kind of stick to the simpler constructs first until you have a better understanding around how RxJava works and how the contract works. And only then, once you hit a wall, to go like to observable.create. Cool. So lastly, I want to talk a bit about testing as well. RxJava gives us a couple of cool constructs on how to test our observables. And the main benefit is because if you just have an observable, there's no threading logic. So that makes unit testing a lot easier than if you have, say, a retrofit backend that you have to work with asynchronous code. So if we have an observable, in this case our API, we can just subscribe to it in our unit tests. And RxJava provides us with a really cool test subscriber class that has all kinds of assertions on the behavior that observable demonstrates. So you can assert the different terminal events, or you can assert the number of values. You can get reference to the values that were emitted, things like that. You can check if a specific value was in the set that was emitted. So that's really handy for testing basically everything in the model layer that presents itself as an observable. For the presenter layer, if you inject your schedulers through, like, for instance, Dagger, you can also really easily unit test things there. We have a couple of schedulers in RxJava, like schedulers.immediate, which, as the name implies, executes immediately and doesn't really schedule anything on the background thread, just executes on the current thread. Sorry. This will help you out most of the time in your unit test, where you can just say, oh, just do this immediately. And you basically remove all the asynchronous behavior from your presenter. If you have more complex requirements, you can use the test scheduler. The test scheduler allows you to manually advance time. So this would allow you to unit test things like delays or complex asynchronous scenarios. Cool. I went a bit faster than I thought, I think. So that's basically all I had for now. Let me know if you guys maybe have questions.